A tangent line. What two pieces do you need to write the equation of a tangent line?
Point and slope.
Point and a slope. Perfect. Okay, now, this is where you have to be a little bit careful. Okay, for your point, part A. Okay, so I see tangent line. I know I need a point and a slope. Okay, my point is going to be at what time? 5. Okay, pay attention or you're going to be confused, and I don't want to go over it again. Okay, because we only have a short class. So, look at your table. What is in the table? Is it the point or the slope? Look at how it's labeled. It's the slope because it's not R. What is it? R prime. That's a slope. So if I look at 5, what's the slope? 2. Okay, so this is 2. That is from the table. Okay? Because it's R prime in the table. So I have to go back and find the point. Read through the paragraph. R prime is the slope, how fast it's changing. But somewhere in the question, it tells you what the radius is. Not the slope, but the actual radius. Okay, so read through it. What does it say? Yes, look right here. Okay, it says, the radius of the balloon is 30 when t is 5. That's your point. Okay, so remember that sometimes they give you it in the chart, but in this case, they tell you in the paragraph what the point is. The radius is 30. And then the chart is actually r prime, which is the slope. Okay, from here, what would the equation of my tangent line be? I have my point, I have my slope.
Y minus 30.
Okay, y minus y1 equals slope.
2 times x minus y.
Yep. Okay, and then what does it say from there? It says use the tangent line to approximate it at what time?
5.4.
5.4. So what am I going to do with the decimal that they give me? Go back and plug it in. Very good. So I'm going to take my 5.4, whoop, and I'm going to plug it in right there. Now, what is 5.4 take away 5? Okay, y minus 30 equals 2 times 0.4. 2 times 0.4 is 0.8. What's my last step, though? Add the 30 across. So I have y minus 30 equals 0.8. Then I'm going to plus 30 here and plus 30 here. So it'll be equal to 30.8. Got it? Okay, now if you keep reading, it asks you a second question. This is throwback to first semester. Is your estimate greater than or less than the true value? The way that you answer that is concavity. So, go back and look through the question. What does it tell you about the graph of R? Because I don't have R double prime. What does it tell me about the graph of R? What does it tell us?
Concave down.
It's concave down. Now draw a concave down graph, then draw a tangent line. Where does your tangent line fall?
Above.
It's going to be above. Very good. So for the second part of the question, I would say tangent line estimate is greater than your actual value because R is concave down, so tangent line is above. And then if you want to draw a picture, you can. Okay, but remember that only drawing a picture would not be good enough. Okay? Alright, part B says find the rate of change of volume. Rate of change of volume with respect to time. What are they asking you to find in part B? The rate of change of volume with respect to time. This dv dt. Very good. Okay, now, this is a related rate. Okay, and I will happily make a video of that for you to review it, but it's not on your test tomorrow, so I don't want to waste our little 30 minutes on it. Okay, so there will be a video of that. You should review it. AP test is coming up, but since it's not on your test tomorrow, we're not going to spend a ton of time on it right now. So skip part B, go to part C. We're doing a right Riemann sum. Okay, to estimate the integral from 0 to 12 of r prime of t dt. Okay, then after we do the right Riemann sum, we're going to explain the meaning, and we're going to use correct units. Okay, there are several of these on your test. So let's do the right Riemann sum first. Okay, I'm going to zoom out a little bit here. Okay, are my delta x's the same or changing in the table? Changing. So from 0 to 2, how wide is it? 2. And then which is my right y value? 5.7 or 4? 4. Plus. Next interval from 2 to 5, how wide is it? 3. What is my right y value? 2. Plus. Next one from 5 to 7, how wide is it? 2. What is my right y value? 1.2. From 7 to 11, how wide is that? 4. And then what is my right side? 0.6. Last one, from 11 to 12, how wide is it? 1. What is my right y value? 0.5. Okay, then when you look at your crop here, you should see that the only number I never used is the first one. That's correct. Okay, then it tells me to interpret. So what is r prime of t measured in the chart? What does it say? Feet per minute. When you do an integral, you multiply the units. So I'm going to come up here for a second. For my integral, remember it's area. It's like length times width. So I would do feet per minute times minutes. What would happen if I multiplied the length times the width? What would I get? You would get only feet. Now, feet measure the change in what? What is r talking about? It's the radius. So I would say it's the number of feet that the radius changed from when to when? 0 to 12 what? Minutes. Yeah? So remember, for an integral, you multiply your units, and it tells you however much the thing changed. So I would say this integral represents the number of feet the radius of the balloon changed over 0 to 12 measured in minutes. Okay? And I labeled that part B, but that was really part C, because remember we skipped part B. So I'm going to fix that now. Okay, last part, part D. Is your approximation in part C greater than or less than the actual integral? Remember, the way that you check that is based on which side you used and whether the function's going up or down. So look at your graph. Is r prime increasing or decreasing? Okay, it's going down. So I'm going to sketch a little picture up here. Okay, my graph is going down. And I used which side?
Right.
The right side. So I'm going to splice it up just into a couple pieces. And then I'm going to use the right side. So right side cut across, right side cut across, right side cut across. Okay, how does the area of each of my rectangles compare to the actual area? Is it too big or too small? Too small. So I would say for my estimation, it is less than the integral. Okay, so my right Riemann sum is less than actual value because, and you have to state two things, what r prime is doing and then which side you used. So r prime is decreasing, so the right endpoint is always the smallest. on each subinterval. Okay? Got it? Okay. So that FRQ is knocked out. What other questions do we have off of the review? Number 3, just since, or the very last page, there's several of these on your test. I just want to go over part A. What would you do? So this is V, and they want you to find V prime. What would you do if you have V in the chart? Okay, it's Joanna's velocity while she's out on a sweet little jog. Okay, and you want V prime. What does V prime stand for? It's a what? V prime is a...
Acceleration.
Okay, it is acceleration, but more generically, it's a slope, right?
Yeah.
So, if I don't have the equation, I can't take the derivative. What is the only other way for me to find the slope? Do the what? Starts with an A. A-rock. Now, when I do A-rock, where does 16 fit on? What interval? From where to where? 12 to 20. Very good. So I'll put A-rock from 12 to 20. Because remember, V prime, that stands for a slope. And so if I want the slope, but I don't have the equation, then doing the y2 minus y1 over, or f of b minus f of a, however you think about it, that's your only real option there.
Pardon this interruption. I just wanted to come on and make sure that you go over with your students that altered schedule today. Remember, we are first, second, third, fifth, then fourth. So please make sure that you share that with your student subs. You also have this alternate schedule. Please make sure you post that schedule on the board so that the students can copy that. It's very important that all the students know that after third we go to fifth, then we will go to fourth period. Thank you.
I'll put it up there in a second. Okay, so V of 20 is 240. Okay, then minus V of 12 is 200. And then 20 minus 12 is 8 left over. Now, a lot of times it'll say indicate units of measure. So I want you to practice that here. If this is meters per minute and I'm taking a slope, what will my answer be in?
Oh, meters per minute squared.
Meters per minute squared. Remember, for an integral, the minutes cross out. But for a derivative, this is meters per minute. And then you're dividing by more minutes. So you want to be very careful about if it's V prime. Okay, Alejandro said earlier, the derivative of that is acceleration. So that's true. It should be meters per minute squared then. Okay, so I'm going to put on top, it's 40 over 8 meters per minute squared. Okay? Now, go down to part B. What is the meaning of this in the context of the problem? Thank you. What is the meaning of that in the context of the problem? Okay, yes, so multiply your units for the integral. So meters per minute times minutes, what happens? Okay, it'd be meters per minute times minutes. These guys cross out. Okay, so it would be the change in meters of her position, except for one thing. They put absolute value bars around it. So what do you call it if they put absolute value bars around it? It's not the displacement anymore, it's the distance. Very good. So the integral from 0 to 40 of v of t dt represents the distance in meters that Joanna jogged. And then that'd be over 0 to 40 minutes. Okay? Now, when it asks you to do a right-Riemann sum, what do you need to be careful about? Look at your chart. Are there any negative numbers in there? Yes, and when you have absolute value bars around it, you need to remember to turn those positive. Okay? Do we have the same delta x each time or changing delta x? Changing. So this would be approximated by, from 0 to 12 is 12. My right y value is 200. Then from 12 to 20, the distance is how far? 8, and your right y value is 240. From 20 to 24, it's 4. And then your right y value's absolute value is what? Positive 220, okay? And then for your last one, 24 to 40, your distance is 6, and then you'd use a 150, okay? And then you do not need to add those up. Okay, then on part C, I'm not going to do it for you, but it says Bob's riding his bike. Bob's velocity is given. So this is his velocity. How would you find his acceleration? A derivative or an antiderivative? Derivative, and then what would you do with 5? Well, it says find his acceleration of 5. You'd plug it in, okay? Alright, we have about 12 minutes. What do we need to do, people? You want to do this one? Or this one? Or this one? There's time for probably one more. No, I was just telling, you're talking about this one? I was just telling you what to do. You just take the derivative. And since it's a polynomial, it's not too hard. If I was going to pick one for you to do, which one? 31. Okay, take a look at 31. It says you have a particle traveling. When is the particle at rest? What do you do? What is the velocity of a particle if it's at rest? Set it equal to 0. Okay, do you have to write the equal 0 on your paper? Yes. Okay, so t squared minus 6t plus 5. Okay, then I can break it up. I'll use t minus 1 and t minus 5. Okay? Then when is my particle at rest? What 2 times?
1 and 5.
1 and 5, great. Okay? So, part A, you're done. Part B, when is it traveling to the right? That's a sign chart. So 1 and 5 go on my little table thingy. Okay, from 0 to 1, say I plug in 0. I get negative 1 and negative 5, but those multiply to a positive. Then say I pick 2. 2 minus 1 turns positive. 2 minus 5 is still negative. Multiply those guys together, you get a negative. Okay, then last one, say you pick 6. These both turn positive. So it goes up, down, up. When is your particle traveling to the right then? Perfect. And I would also label this, remember this is v of t, so it's telling you how position is changing. So it'd be from 0 to 1, union, 5 to infinity. If it said justify because v of t greater than 0. Okay, part C. How do you find acceleration? Do the what? The derivative. A of t equals v prime of t, and then you take the derivative. Derivative of t squared minus 6t plus 5 is what? 2t minus 6. Very good. Okay, part D. When is the velocity increasing? Okay, what is the slope of velocity called? Acceleration. And if I want velocity slope to be positive, I want acceleration to be positive. So this is a second derivative test. Now, if it's 2t minus 6, I can just take that 2 out, and I get a t minus 3 left over. So my critical number is going to be 3. If I plug in 0 to this, 0 minus 3 comes out to be negative. 4 minus 3 comes out to be positive. And remember, acceleration is the slope of velocity because it's the derivative. So when my acceleration is negative, my velocity is decreasing. Acceleration is positive, velocity is increasing. So which interval do we want for that one? 3 to infinity. Very good. Because a of t greater than 0. Okay, part E. When is the speed increasing? What are you looking for? V of t and a of t have the same sign. So look at your chart. When do they have the same sign? From 1 to 3, they're both negative. And then from 5 to infinity, they're both positive. So from 1 to 3, union 5 to infinity. Okay, because V of t and a of t have the same sign. Okay? Part F asks you for position. I was given velocity. If I want position and I have velocity, I have to do what? Antiderivative. And remember, you should write this first before you do it. So x is the integral of v of t. And then you're going to do it. Now, my first term was a t squared. What's the antiderivative of that? If it was a t squared, 1/3 t cubed. Next term was a minus 6t. That's going to turn into a what? T squared with divide the 2 on the 6. Now it's a 3. Antiderivative of 5 is 5t plus what? C. And then notice they gave you a point here. That's how you find your constant. Remember, this one is called the general solution. Okay, when you find that number, it's called the particular solution. Okay, so it'd be 5 equals 1/3 3 cubed, 3 times 3 squared, 5 times 3 plus c. Okay, and you should be able to do that without your calculator, but we don't really have time right now. Okay, then part G, find the position and the velocity at 1. Okay, and then it says determine whether it's traveling towards or away. Remember, the two components of that are which side is it on? Okay, and then which direction is it going? And you should know how to answer that from other questions. Okay? I'll put the schedule up here in case you weren't listening. Okay, you go 1st, 2nd, 3rd, then you go to 5th, then you go to 4th. Okay? So if you'd like to see it, there it is. And then if you need help on this review, message me on Remind and let me know. Okay, and I will be happy to help. I love to help. Okay? And then if 4th period does, if 3rd period does questions that are different than yours, then I'll video it and post it. Because we'll probably do one of those other FRQs. Okay? Yes, ma'am. Oh, yeah, that's fine. Do you want a green sheet though, so it matches everybody else, or no? Okay, I'm gonna give you one just since we have a sub, so that she doesn't think we have like some girl issue. And then I did video the examples. Okay. Have a great day! Huh? Oh, tomorrow's the calculator part of the test. And it's going to cover points. So I would say make sure, and actually at the end of the test, I put a key with the buttons of what you have to do. So you have to do math 8, math 9, integral, and then remember the difference between if it's average value or average rate of change. So remember, average rate of change is a slope, average value is the same. So if you have velocity and you want average velocity, that's average value. But if they ask you for average acceleration, that's like a slope. So that'd be average rate of change, the FP. And then you have some anti-derivatives on it.
So, like,
You have some graphs where you have to do area.
mine, 50, 50, 10, 10.
Yeah. I made it last night at 3 a.m., so I'll be honest, I don't really remember what's on it. That's algebra 2. Y'all just have your same review.
You have a good one who's joining.
Bye!